Hey Year 10, it's time to do 3H, which is rational indices. Now, you might see that I've got written like all over the page here, there's a heap of different roots. So some of them are square roots, we've got cube roots as well. So we should be familiar with using those ones so far, but they can actually be expressed in another way. So you might see up the top here, roots can also be expressed as powers. So again, we have a rule that I've shown you here, and we can kind of transfer between these two, but I want to show you in an actual example here. So with this root here, this is the square root of 2, yeah? Now, what you might notice up the top here in our kind of general equation with the root is there's a certain number that goes there and a certain number that goes there. Now, with a square root, there's actually a 2 here, but we don't necessarily write it. Okay, so remembering that there's a 2 there might help you out if you want to, when you're using the rule. But also here we have something in the power here. Now, our 2 here is just 2 to the power of 1, isn't it? Okay. So what we can also do, rather than expressing it just like this, is change it over to this. All right, so we could write this also as 2 to the power of m on n. So m would be our 1 and n would be 2. So 2 to the power of half is the same as the square root of 2. Okay, so if we had like anything, square root of 10, that just means 10 to the power of a half. Okay, so square root and to the power of the half are the exact same thing. And you might use that a fair bit in methods if you choose to continue to do that next year and the year after. Okay, so what we're going to be doing for this first example is just changing between index form and also your root form as well. So I've already done this example. I didn't realize. So we can change this to 10 to the power of 1/2. We go over here. See how there's a 3 here and there's a 1 there. That's just 5 to the power of 1. So we can also write that one as 5 to the power of 1/3. Okay, whatever number is there becomes that denominator in the power. Okay, now let's have a look over here. This is just a square root. Remember, people don't write that 2 out the front there, but if you want to put it down to make it a bit easier for you, that's fine. We could write this one as 13. Now that 2 goes down the bottom and that 3 would go up the top of the fraction. So 13 to the power of 3 on 2 is the same as that. Now let's look over at D, and you might notice that there's something a little bit extra out the front there. So that's just 3 times this whole thing, but it doesn't really change too much. The 3 will stay there, and we need to change this around. Okay, so remember, our 6 will stay, and our little fraction in the power, the 4 would go down the bottom, and the 5 would go up the top. Now we can't combine these two things. Okay, the bases aren't the same. This is something you might learn a little bit later, but we'll just leave it exactly like that. Okay. All right. So let's do the same sort of thing, except rather than changing them from roots to powers, we're now changing them from powers to roots. Okay, so this one over here, I want to look at the denominator. Now I don't even know how to say this properly, but this is the 4 root, and our 2 goes down the bottom, and our 3 would go just there. Now 2 to the power of 3 gives you 8. Okay, so we might be able to write that there as well. I'm just going to. There we go. So same thing. Let's go over to B. Now 2's down the bottom, so this could be written as the square root of D to the power of 3. Same thing. And the last one of these ones is a 5 down the bottom, so it's a 5 root, and our x goes there and 1 just there. We don't need to write that one though. Okay, I've just put that in there maybe to help you if you're really reliant on looking at that rule. Okay. Alright, so last couple. It's asking us to simplify. Okay, so this is going to require some of the stuff that we've done in previous lessons. Alright, so we've got a square root over the top of the whole thing here. Remember, we can sort of break this up because it's 16 times x to the power of 6. We could write this as the square root of 16 times the square root of x to the power of 6. Okay, now hopefully we know the square root of 16 is 4. There we go. So this is pretty much finished, but you could write it in another way as well, based on what we were doing before. This is, our root form or surd form. We can also change it to power form. So this would be x to the power of 6 on 2, which is 4x to the power of 3. Alright, last one. Now let's remember some of these index laws. When you've got, when you've got a power on the outside here and you've got a fraction on the inside, remember that power will apply to the top and the bottom. Okay, so that's going to give us 8 to the power of 1/3 divided by x to the power of minus 6 times 1/3. So that's going to be 8 to the power of 1/3. Let's just leave it like that. Divided by, now minus 6 times 1/3 is minus 2. Okay, now let's start having a look at what's going on here. We've got a negative power there. We were working with that not long ago, last lesson. We've got 8 to the power of 1/3. Okay, let's change this top first. So 8 to the power of 1/3, that just means you cubed root of 8. And down the bottom here, we've got that negative power. We can actually move that to the top as well. I might just leave it for now though, because I want to focus on this first. So cube root of 8, that just means what number multiplied by itself 3 times gives us 8. Now I know 2 times 2 times 2 gives you 8. So the cube root of 8 is 2. And this x here, remember it's got a negative power. We don't like that. So we can move it to the numerator, but we need to change it to a positive power. Can you see that? No, sorry. Awesome. And we're done. So have a go at those questions, guys. If you've got any, if you run into any problems or you have any questions, let me know and I'll give you a hand.